So this section is 4.3, and it is talking about recognizing systems with no solution or infinitely many solutions. So let's take a look at an example where you have x minus 2y equal to 4. And then you have negative 2x plus 4y, and that is equal to negative 8. Okay, so we want to do the same thing we've always done. Can we add the equations and one of the variables drops out? No, that's not the case. So I'm going to eliminate the y's since I see that they're opposite. Well, this is opposite sign too, so let's do that one. So I'm going to multiply by 2 because then 2x and negative 2x will cause this variable to drop out. So 2 times x is 2x. 2 times negative 2y is negative 4y. And then 2 times 4 is 8. Now bring down the other equation. Don't need to change that. And then when I add, the variable x drops out. Oh, but look at this. When I add the y variables, it also drops out. And the constant even goes to 0. So I'm getting 0 equal to 0. This is telling me something very interesting because I've never seen this before. So this is saying something very, very clearly. So let's put this into slope-intercept form and graph them and see if we can understand why I'm getting 0 equal to 0. So if I have x minus 2y equal to 4, I'm going to subtract the x. So negative 2y equal to negative x plus 4. Divide by the negative 2. So I get y equal to 1/2 x minus 2. So there's my first equation. Now my second one is negative 2x plus 4y equal to negative 8. I'm going to add 2x to both sides. So I get 4y equal to 2x plus, nope, not plus, it's minus in it. So minus 8. I'm going to divide everything by 4 to get rid of the 4. So y is equal to 1/2 x minus 2. And what do you know? Both equations are the same equation. So if I graph this one and I graph this one, they're both going to land on top of each other. So this is the same equation. So this is telling me that I have infinite solution. And so on a homework assignment or test or quiz, when you get something where something equals something, it doesn't have to be 0 equals 0. It could be actually x equal to x, or it could be negative 24 equal to negative 24. As long as it's a true statement, then you have infinite solution. And that's what you have to state. You'll have to choose that to show that you understand what you found. So now let's go ahead and do it with another problem. Let's say we have 3x plus 3y equal to 6. And then we have x plus y, and that's equal to 1. Okay? So again, I want to do the elimination method. I'm going to multiply the bottom one by negative 3 so that my x variables drop out. So my first equation is still 3x plus 3y equal to 6. And then I get negative 3x minus 3y equal to negative 3. The x's go to 0, the y's go to 0, but 6 minus 3 is 3. And that's not a true statement. 0 does not equal 3. So in that case, that's interesting as well. So what is that telling me? Well, if we put them both into slope-intercept form, the 3x plus 3y equal to 6, minus the 3x from both sides, we get 3y equal to negative 3x plus 6. Divide everything by 3. I get y equal to negative 1x plus 2. Okay, let's do the other one now. That's x plus y equal to 1 minus x from both sides. I get y equal to negative x plus 1. Well, what I'm noticing is they have same slope. And so if they have same slope, that means these are parallel lines. Okay, and so since they're parallel lines, there is no solution. They're never going to intersect. So we have a no solution here. And so that's something you have to point out as well. If you get something that doesn't equal itself in the end, and the variables did drop out, then if they don't equal, then you get no solution. And so you need to state that. You can't just say 0 does not equal 3. You have to say what does that mean, okay? Just like when it was infinite solution.